Now once we know the types of errors, let's see how the errors are calculated, how the mean value is calculated. So we know, we have already learned that we take many readings. So say there is a physical quantity A and its reading in the measurement are A1. We have taken many measurements, A1, A2, A3, A4, A5. Say we have taken 5 readings. We cannot say which reading is accurate. Every reading may have some error. But question is, what is the true reading? What is the mean value? Or what is the true value? So mean value or true value will be, which can be represented by AM and it can be represented by A bar. True value or mean value will be A1 plus A2 plus A3 plus A4 plus A5 by 5. So you take many readings, maybe 7 readings, maybe 8 readings, then take mean of all those. Each reading may have some error, but mean of all those can be considered as a true value, true reading. And yes, like it is shown here, I can write A bar or AM as 1 by n sigma I is equal to 1 to n AI. Now what is the meaning of it? It means AI, the value of I start from 1 to n. It means A1 and sigma mean addition of all those. So A1 plus A2 plus A3 plus AN, n readings divided by n. This is mean value. So here mean value is mean of all the readings taken. They can be 5 readings, they can be 7 readings, they can be n readings. Mean of all those will give you a true value. So first point I can say here is AM or A bar is 1 by n sigma I is equal to 1 to n AI. This is the general formula for the mean value. Now coming to the next, and that is mean absolute error. Absolute error. So we learned mean value or we learned true value. Now error, absolute error. The error in the first reading, we know the first reading A1 and we know the true value. So we can always say true value minus first reading will give you error in the first reading. Similarly, delta A2, error in the second reading will be true value minus second reading. Error in the third reading will be true value minus third reading, and so on. But instead of just writing this, sometimes there is a possibility that A1 is greater than AM. So when we are taking the individual errors, individual absolute error, one can be positive or negative. But when we are taking mean absolute error, it is the mean of all these errors but absolute form. It means positive value of them. So if delta A1 is AM minus A1, here AM can be bigger or A1 can be bigger, but in case if AM is bigger, it will be positive. If A1 is bigger, then it will be negative. But when I write like this, it means I am just talking of the positive value of it. Maybe AM is big or maybe A1 is big. So when I talk about mean absolute error, it is the mean of all absolute errors. Delta M like this. It can be written as delta A1 plus delta A2 plus so on divided by N. So here we can say that mean absolute error is delta AM bar as, in the same pattern, 1 by N, sigma I is equal to 1 to N, delta AI. The error, sum of the error in each individual. It can be delta A1 absolute value plus delta A2 absolute value plus delta A3 absolute value and mean of all these absolute errors, and this will give you the mean absolute error. So I hope it is clear. First we talked about the true value or the mean value. Then we are talking about the error in each individual reading. And now the absolute value, the positive value of those errors will give you absolute error. And mean of all those absolute error will give you mean absolute error. So that's how we have absolute errors. And now, as we have learned, so our reading should always be written as AM plus minus delta AM. Our reading should be always AM plus minus delta AM, or mean value plus minus delta A bar. Mean absolute error. This should be our final reading, that the value observed is this much. That shows the range of error and that shows the true value. Now coming forward, we have some more terms, relative error and percentage error. Now relative error, this is also a quite popular term. It is represented by delta. It is mean absolute error divided by mean value, or delta A bar divided by A bar. And then we have a percentage error. It is delta into 100, or mean error divided by mean value into 100. This will give you a percentage error. So many times we will be calculating mean value, many times mean absolute error, many times relative error, and also percentage error. With one simple example, everything will be clear. Now we take one example, that one numerical example that gives you all clarity about the different kind of errors, absolute, relative error, percentage error that we just talked about. In an experiment of acceleration due to gravity using simple pendulum, 5 readings were taken. The first reading is G1, 9.7 meter per second square. Second value of acceleration due to gravity is 9.75 meter per second square. Third value of acceleration due to gravity is 9.80 meter per second square. Fourth value of acceleration due to gravity is 9.85 meter per second square. And fifth value of acceleration due to gravity is 9.90 meter per second square. So there are 5 different readings of acceleration due to gravity. More the number of readings, you are more closer to the accuracy. Now question is, which is the true value? How to find the mean acceleration due to gravity? So the true value of acceleration due to gravity will be g1 plus g2 plus g3 plus g4 plus g5 divided by 5. So true value of acceleration due to gravity comes out to be 9.7 plus 9.75 plus 9.80 plus 9.85 plus 9.9 divided by 5. There are 5 readings, and by calculating all that we get 9.80 meter per second square. We can call it G bar or Gm, the true value of acceleration due to gravity. Now moving forward. So we have acceleration due to gravity, 5 readings. We have observed a true value. Then comes absolute error and mean absolute error. So absolute error, and then we'll come for mean absolute error. If I say what is absolute error in the first reading, it will be 9.80 minus 9.7, 0.10 meter per second square. Similarly, absolute error in the second reading will be 9.80 minus 9.75. So it is 0.05 meter per second square. Absolute error in the third reading, 9.80 minus 9.80, it is 0. Absolute error in the fourth reading, delta G4, 9.80 minus 9.85, so it is minus 0.05 meter per second square. Absolute error in the fifth reading will be 9.80 minus 9.90, so it is here minus 0.10 meter per second square. So we have got absolute errors, and then comes mean absolute error. So I am just removing these, and in case if we are interested in mean absolute error, delta Gm, it is delta G1 plus delta G2 plus delta G3 plus delta G4 plus delta G5 divided by 5. But when we talk of this, it is absolute value. It means it may be a positive error or a negative error, but we'll talk of the positive value only. So this will come out to be 0.1 plus 0.05 plus 0 plus 0.05 plus 0.1 divided by 5 and 0.06 meter per second square. So I've got two results. One result is, what is the mean value? So first result is the mean value 9.8, and second result is 0.06 meter per second square, that is mean absolute error. Two major results that we have obtained, and for finding mean absolute error only the positive value is to be used. So we have Gm, and that Gm is 9.80 meter per second square. We have delta Gm, and it is 0.06 meter per second square. Now moving forward, we want to know something else, and that is what is relative error and what is percentage error. So if you are interested in relative error, it is delta GM by GM. 0.06 divided by 9.80. It comes out to be 0.00612. If we are saying what is percentage error, it will be delta into 100. So it comes out to be 0.612%. Now, how to write the result? What are options to write the result? What is your final reading? What is your final result of the observation or the measurement? So final result can be written in two ways: GM plus minus delta GM. Now that GM is 9.8 plus minus 0.06 meter per second square. This is one way of writing the result. Or second way of writing the result can be GM plus minus percentage error. This is 9.80 meter per second square plus minus 0.612% is the final result, meter per second square. Now when we say that our final result is this much, what is the meaning? It means the value of G can be anywhere in the range 9.86 meter per second square to minus of it 9.74 meter per second square. So when we say the result is acceleration due to gravity after observation is found to be GM plus minus delta GM, it has a range 9.8 plus minus 0.06. It means it lies somewhere, anywhere in this range, any value in this range. And also with the percentage error, we can say the value is, otherwise mean value is 9.8 meter per second square, but its value can vary in the range of 0.612% plus or minus. So that's how we have the meaning of mean value, true value, errors, absolute error, mean absolute error, relative error, percentage error, and that's how we represent our result. Now on the similar lines, as we have calculated acceleration due to gravity, the mean error, the mean absolute error, and all other the relative error and percentage error, let's do this one more example for little more practice. Question says, here it's about refractive index, calculation of refractive index. We know every glass has a refractive index which decides or explains the amount of bending done by this particular glass when the light falls on it. So the refractive index, which is represented by mu, it is mentioned in an experiment refractive index of glass was observed to be 1.45. So one reading of the refractive index is 1.45. Second reading of the refractive index is 1.56. Third reading of the refractive index is 1.54. Fourth reading of the refractive index is 1.44. And fifth reading of the refractive index is 1.54, and sixth reading of the refractive index is 1.53. So the refractive index was measured, and during the measurement of refractive index 6 different readings are taken, and these are the values of refractive index observed in 6 different readings. Question is, we need to get the mean value of refractive index. So first part is how to get mean value of refractive index. We will say mean value will be mu1 plus mu2 plus mu3 plus mu4 plus mu5 plus mu6 divided by 6. So, if I am interested in the mean value, we just write all these values, divide by 6 and we'll get it 1.51. Mean value of refractive index. Now, B part. What is mean absolute error? What is mean absolute error? So, let me find the absolute errors in every reading first. Now, we have this true value or mean value. Absolute error in the first reading will be mu m minus mu1. So, this is 1.51 minus 1.45 and it is 0.06. Similarly, error in the second reading will be mu m minus mu2. 1.51 minus 1.56, but here this is minus 0.05. But whenever we are adding about the mean absolute error, only the positive value will be taken. Similarly, the absolute error in the third reading is mu m minus mu3. Mu m is 1.51 and mu3 is 1.54, so it is minus 0.03. Similarly, error in the fourth reading, mu m minus mu4. So it is 1.51 minus mu4 is 1.44. So it is 0.07 plus. Similarly, mu5, error in the fifth reading, mu m minus mu5. 1.51 minus, fifth reading is 1.54. So here it is minus 0.03. And in the sixth reading, mu m minus mu6. 1.51 minus, sixth reading will have a value 1.53. It is minus 0.02. So we have here 6 different readings. This is a positive value, 0.06. This is a negative value. This is again a negative value. This is a positive value, negative value, and negative value. But when we are looking for mean absolute error, if we are looking for mean absolute error, that stands for delta mu m. Only the positive of all these absolute error will be added. So here I should write 0.06 plus 0.05 plus 0.03 plus 0.07 plus 0.03 plus 0.02 divided by 6. So we are getting this mean absolute error here as 0.045. So the two readings, one side the mean value, that is 1.51, and other side the mean absolute error, which is 0.045. Remember, the about mean absolute error, the errors are just added. So here my result is mu m plus minus delta mu m. It has a value 1.51 plus minus 0.045. The refractive index have no unit because it is just the ratio of speed of light in vacuum divided by speed of light in the medium. Then fractional error. So if in part C we want fractional error or relative error, so fractional error will be delta mu m by mu m, 0.045 divided by 1.51. Then percentage error. So if we want percentage error, delta mu m divided by mu m into 100. It is 0.045 divided by 1.51 into 100. And that comes out to be 3%. So my result ultimately here can be written as mu m plus minus delta mu m. So result can be written as of refractive index reading is 1.51 plus minus 0.045 or 1.51 plus minus 3%. So anyway we can express our result of the calculation of refractive index. This is certainly going to be quite helpful when you are writing your observation and results in the practical experimental copies.